All right, some more review. This is 1.1, adding and subtracting rational numbers. So we're only going to be adding and subtracting today. Remember, rational numbers covers decimals and fractions. So our standard for today is I can add and subtract decimals and fractions with like and unlike denominators. So in the key terms, we just put reminders for how to add and subtract fractions. So we need to find a common denominator. So the steps are as followed. We first find the least common multiple of the denominators, which is called the least common denominator. Remember, that's the least common multiple, which means the numbers need to get bigger, not smaller. Then we change each fraction using equivalent fractions to make the denominators the same as the least common denominator. And that means that everything we do to the denominator, we have to do to the numerator. Then we'll add and subtract the fractions as we wish. So once we get them in common denominators, we can add and subtract the way we would like to, right? Using our rules, just like integers. So we're going to first start with decimals, get us groovy into these. So the main thing we need to remember with decimals is that we have to line up the decimal and the place values. So we may need to add zeros. We use the same rules that we use for integers. So if they're the same sign, we just add and keep the sign. If they're different signs, we subtract the absolute values and keep the sign of the larger absolute value. So this first problem, these are different signs. So we're going to technically subtract. So absolute value, absolute value. So we're going to go 1 3/10, take away 4/10. We need to borrow 13, 12, 11, 10, 9. And then since 1 3/10 has a larger absolute value than the 4/10, we will leave it as positive 9/10. So let's go down to this one. This is subtraction. So remember, the only rule for subtracting is to add the opposite. So we're going to go add and change the number behind it to its opposite. That's my negative, so don't mix it up. Now we can see they're actually the same sign. So that's really nice. We just add them together. So we're going to go 3 2/10 plus 1 6/10. So 8 and 4. Bring my decimal down. They're both negative. So my final answer is also negative. Add and keep the sign. But that's why it's so important to switch it to add the opposite so you can see that they're actually the same sign. All right, last one. It says 23 8/10 plus x, and x is going to be negative 41 3/10. What that means is we're just going to take this and plug it in right here. So the problem is 23 8/10 plus negative 41 3/10. So this is opposite signs. It's similar to our first problem. First problem is the same, so we subtract their absolute values. So 41 3/10, take away 23 8/10. We have to borrow 13, 12, 11, 10, 9, 8, 7, 6, 5. Borrow 10, take away 3, 7, and then 3 take away 2, 1. Bring down your decimal. Now we have to look at who has a greater absolute value, 23 or 41. 41 does, so we are going to actually make this negative 17 5/10 because this one has a greater absolute value. All right, so now we're going to do with like denominators, so that means all the denominators match. So these are awesome because all we have to worry about is the numerators. So we keep our denominator and we combine these just like using our integer rules. So 6 plus 9 is 15. Done. Do not change these to mixed numbers. Total waste of your time. All right. So again, keep the denominator and only concentrate on the numerators. Notice I took the negative with that. This is actually 2 plus negative 4. 2 plus negative 4, so we're going to go 4 take away 2, right? Different signs. Get 2. This has a larger absolute value, so we keep it negative. Negative 2 over 7. Okay, we got negative 3/8 minus 5/8. Let's practice using add the opposite. We're going to keep our denominator. And I have negative 3 plus negative 5. Well, they're the same. Makes it so nice. 5 plus 3 is 8. And then we're going to make it negative because they're both negative. Now, what do we do with our fractions? If we can, we have to reduce. So 8 and 8 can both be reduced by 8. So we're going to get negative 1 over 1, which then gets reduced to just negative 1. So we have to reduce. It does not have to be in the directions any longer. It is just known that we reduce all of our fractions. All right, the last one is a little tricky. It doesn't really look like a fraction problem. This can be broken up as 2 over 7 plus negative 4 over 7. And if you see, that's actually the exact same problem as up above. And so we get negative 2 over 7. All right, so here's some decimal problems. This would be a really great place to pause so you can practice some more decimal problems on your own. So let's pause, try out adding and subtracting decimals on your own. All right, hopefully you paused. So this first one is 3 and 6200ths, take away 18 and 5700ths. I would add the opposite. They're opposite signs, so I'm going to go 18 and 5700ths, take away 3 and 6200ths. So 5, 9, 4, 1, bring down the decimal. This has a larger absolute value, so my final answer should be negative 14 and 9500ths. Those were not the same sign. All right. Now these are the same sign, they're both positive, so we can just add and keep the sign. We just need to make sure we line decimals up. So remember, whole numbers always have a decimal in the back. The 9 does not just tuck underneath the 5. They have to line our decimals up. So then we get 5, 4, 2, and 12. And it is positive because both of these were positive. So that might have been what tricked you. You stuck the 9 under that 5. But we had to line the decimals up when we add. All right, last one. Same sign, so we're just going to add them. I'm going to go 18 and 3/10, 5 and 7800ths. And again, I'm going to make sure I line those decimals up. So we have to add zeros in there. Then I can add them, so 8, 10, 13, 14, and 2. Bring my decimal down. They're both negative, so my final answer is also negative. All right, these are unlike denominators, which means we're going to have to find a common denominator. So this is where your multiplication chart comes in. What number can they both be multiplied to get to? We're not trying to divide these numbers by anything right now. We're actually trying to multiply. We're always going to multiply. That's why it's a least common multiple. If you have a hard time remembering that, just think that. Least common multiple means I'm going to multiply. So if you look at your multiplication chart, 6 and 8 both can multiply to get to 24. 6 gets multiplied by 4. Notice I do it to the top and the bottom, so this becomes 20. This one can be multiplied by 3, and so we get 9. Once the denominators are common, you can then just deal with the numerators. We get 29 over 24. So even when you have mixed fractions, you have to still have a common denominator. And so we still have to find out what 4 and 15 can go into. Sorry, getting a drink of water. Now, our multiplication chart doesn't really help us with 15s, so we may need to make a list of some kind, right? Our multiplication list. So for like 4, all right, it's 4, 8, 16, 24, 28. Nope, I skipped 20, 28, sorry about that, 32, and so on. And then like 15, 30, 45, 60. So it might take a little bit to get to it, but the one that matches is going to be 60. That's just 4 times 15, unfortunately. So we're going to go negative 7. And then we're going to times this by 15, and we're going to times this one by 4. Sometimes you have to do that. So we get 15 over 4, not 4, 60. And we're going to add it to negative 2 and 8 over 60. Now once we have a common denominator, you can add them as you wish. I know some people like to change them to improper, some people like to just add them. These are both negative, so we can just add them. So 7, 8, 9, and then 15 plus 8, right, would get me 23 over 60, but we need to make sure it stays negative because they are both negative. Okay, so this one you're going to take this, plug it in here, so it's 2 3/8 minus negative 1 5/6. This minus does not take care of this negative. Minus does not take care of the negative. So we would add the opposite first, and notice now they're the same. They're both positive. So that's actually going to make it a lot easier. So why don't you pause here and see if you can finish this. Hint, hint, denominators 8 and 6. Here's an 8 and a 6, so you already know what the common denominator is. So pause, let's see if you can finish this. And then once you do, unpause. So this one should have been multiplied by 3. We get 2 and 9 24ths plus, this is times by 4, and we get 1 over 20 24ths. So, and look, they were actually the same too as well. Look, 9 24ths, 20 24ths. Anyway, so you get 3 and 29 24ths. But that, you can't have an improper with a mixed. So you have to fix this because we cannot have an improper in a mixed. So since 29 is more than 24, we have to get rid of 24 of these. So 29 minus 24 is 5. So that's my remainder. Right? So then this is 1 whole. Oops, look at this, 1 whole. So we put that into here, we get 4 and 5 24ths. That's our final answer. So things to remember, always line up the decimals and place values. And always find a common denominator. Always reduce. All right, independent practice problems. If it helps, this is 3, 2, 1. So if you need to circle those to help separate them, sorry, I should have used circles myself, but so if you want to circle those, but we've got fraction, fraction, and a decimal problem. And then make sure those get done. All right, until next time.